Hello students, today we'll be discussing about another topic, that is radioactive decay 7.06 from physics higher tier. Okay, let's start. So the breakup of the unstable nuclei is called radioactive decay. It happens at random and hasn't effect by pressure, temperature or chemical change. You can't tell which nucleus is going to break up next or when. However, some types of nucleus are more unstable than others and decay at a faster rate. Okay, so what is radioactive decay? That means in atoms, some of the nuclei, that is the central part of the atom, remains unstable. That means they are always ready to react, that is always ready to decay, and these type of atoms are known as radioactive atoms, and they contain radioactive material, and the breakup of the unstable nuclei is known as the radioactive decay. Okay, and it is not affected by any pressure, temperature or chemical change. This is a natural process. Okay, so first comes like the activity. What is an activity? The activity of a radioactive sample is the average number of nuclei breaking up per second. That means at a rate at which the average number of nuclei is breaking, this is known as the activity, and this is measured in becquerels, that is BQ. Okay, so the activity means the radioactive sample is the average number of nuclei breaking up per second. That means per second at a rate at which the nuclei is breaking. Okay, the number of nuclei is breaking. For example, that is iodine 128 decays by shooting out beta particles. Okay, that is a beta radiation or beta decay takes place in iodine 128. If in a sample 40 nuclei break up every second, then 40 beta particles are shot out every second, and the activity is 40 becquerel. That means if the activity is 40 becquerel, you can assume that, or you can take into consideration that every second 40 particles are being shot out. And if the activity is like 50 becquerel, that means 50 particles per second, and if the activity is like 60 becquerel, that means 60 particles per second. Okay, so this is a half-life graph, activity graph, and from the graph we have to calculate the half-life. Okay, so what is half-life? It is the time taken for a half of the nuclei to decay, or the time taken for the activity to be halved. That means the half-life is the time taken for a nuclei to decay or the activity to become half. That means if we consider 40, this is 40 at 0 minutes, and the half of 40 is 20, that is 20 in 25 minutes, and the half of 20 is 10, that is 50 minutes, and the half of 10 is 5, that is 75 minutes. You can see the difference between the time is same, that means 25, 25 and 25. That means the half-life of this sample is 25 minutes. That means the activity is becoming half at every 25 minutes. Okay, so this is the time, the graph time in minutes is 0, 25, 50 and 75, and the activity is becoming half, that is 40, 20, 10 and 5. Okay, as you see, the sample of iodine 128 decays as time goes on. There are fewer and fewer unstable nuclei left to decay. Okay, that means the amount of decay it goes on, the fewer particles are left to decay, so activity gets less and less. After 25 minutes the activity is half of its original value, and another 25 minutes the activity is again halved, and this process continues. Okay, now this is the half-life, that is I have told you earlier, the time taken for the half of the nuclei to decay. That means if it is 40, it becomes 20, if 20 then it becomes 10. Okay, these are some of the half-life given. It might be in days, it might be in years, it might be in weeks, or it might be in minutes. So these are the radioactive isotopes, and these are the half-lives. Okay, to get a graph like on the left, Giger-Muller, that is GM tube, is used to detect the radiation from the sample. Provided you allow to background radiation, the number of counts per second is proportional to the activity. that is the number of counts is proportional to the activity. That means they are directly proportional to each other. If one increases, the other also increases, but not equal to it. Okay, they are not equal, they're not the same, they are proportional. Okay, because not all beta particle go into the detector, some are also deflected, they are also passed away. Okay, with experimental results, the points on the graph are irregular because decay is a random process. You cannot expect the decay to be to occur at a constant rate. It might take at a random place, at a random process, at a random time. Okay, so decay is a random process. Okay, the curve is really a line of a best fit. The curve we draw is actually a line of a best fit. Okay, and if we follow the random path, that it would not have been a smooth curve. Okay, moving to the next page. This is you can see new atoms from old. Okay, the breakdown gives the new atoms, that is when an atom shoots out of an alpha or beta particle, the number of protons in the nucleus changes. Okay, so if a nucleus shoots out, the numbers will change. Okay, we'll see alpha decay and beta decay by degrees. So this is proton and this is neutron, that is radium 226 nucleus decay to give radon 222 nucleus. That means an alpha decay took place here, where 2 proton and 2 neutron is being shot out. Okay, so an alpha decay always removes 4 of the mass number and 2 of the atomic number from the atom. That means if you can see the equation here, that is radium is 226 and 88, and when it is going through an alpha decay, it is becoming radon, that is 222, and it becomes 86. That means 2 of the atomic number has been removed and 4 of the mass number has been removed, and this is an alpha sign, that is upper part it has 4 and the lower part it has 2. So are you clear? That is, if alpha radiation takes place, it will remove 4 number from 4 from the mass number, that is upper number, it will take away 4, and from the lower number it will take away 2, and which will change the identity of the atom. It was radium, and after the alpha decay it has become radon. Okay, the equation uses proton plus neutron, that is the upper one, and the relative charge, that is 2 plus. In the equation, the top numbers balances, that is 226 equal to 222 plus 4, and the total charge doesn't change, but the bottom numbers balance, that is 88 equal to 86 plus 2. Okay, the total here also the total proton number doesn't change, and if you add these two, you will again get radium. Okay, so when a radium atom goes an alpha decay, it changes to radon, and because the alpha decay take away 4 from the mass number and 2 from the atomic number. Okay, now beta decay, which comes like beta decay. Beta decay do not make any change to the mass number, but it adds up 1 to the atomic number, because let's just look here. When an iodine 128 nucleus decays, a neutron changes into a proton. Okay, a neutron changes into a proton, that is an electron. The electron beta particle is a short out. That means let me tell you one thing, that is an beta decay is an electron that means you can beta is negatively charged, so you can connect it with an electron. Okay, the nucleus now has 1 less neutron than the before, but one more proton, making it nucleus xenon 129. That is again a nuclear equation balances. That is, just have a look here. It's iodine 128, it has an atomic number of 53. It has been changes into 12854, that is xenon, because beta added 1 electron to the proton number, because here atomic number remains 53, and since it is an electron emitter, it has given on 1 electron to the atomic number. That is, it was 53 before decay and it becomes 54 after decay. That is an beta decay. Okay, a chargeless, almost massless particle called antineutrino Antineutrio is almost a chargeless, massless particle that is also shoot out during a beta decay. And gamma decay do not make any change by itself. It doesn't alter the number of protons or neutrons in the nucleus. Okay, the gamma decay do not make any change to the atom, but what makes the change is alpha takes away 4 from the mass number and 2 from the atomic number, whereas beta decay keeps the mass number constant and it adds up 1 to the atomic number. Okay, I hope you are clear with the lecture. If you have any confusion, please let me know on the comment section, and the answers of the exercise question will be on the link of our description box. Okay, stay safe.